back. Here's a little private, 2 minutes of fame private talk. I'll just redo kind of what I did for that little presentation. So this model here, this is the 3D model that I brought to Maker Faire essentially. And while I had this door hinged, there wasn't any mechanism that really constrained the door to that 0 to 60, 90 degree range. And there wasn't any mechanism to kind of, how does this door actually lower in real life? So since Maker Faire, I've been working on this drawbridge mechanism, which is really just based on a drawbridge style lowering system. And you've got these geared braces that are bolted to the door, and this geared drive shaft that runs between them. And when you raise and lower the door, you can see how this drive shaft is driven with a gear over here. You don't see the timing belt, but there's a timing belt that drives this gear. It turns this whole drive shaft, this carbon fiber drive shaft, and you can see this cap moving, how this thing sort of opens and closes and kind of comes down and parks in that little park down there. Anyway, the focus of the talk was how to make this particular gear, which I 3D printed everything, but I wanted it out of something harder in plastic and better machined. So I can show you how that thing gets cammed. So this is the little gear. It's only like 1.5 inches long, very tiny. And I'll turn on the cam fixture. This is a model, a representation of the vise in the pocket NC. And the white stuff is 1 inch thick Delrin stock rod that's going to be milled out to create this thing, this gear here. And I'm going to switch into the cam workspace where all my cam strategies are. I will do a regen on all of these, what are called strategies. These are paths that a cutting tool will take to carve out this piece. And I have to do a regen. When you switch out and you come back into cam, it invalidates your workflows. So if I highlight all these, you can actually see these are called tool paths. These are computed paths of a bit to cut out this part you asked for. And when I can run those in simulation, take a little while to fire up the environment. I'll go back to the beginning, show the stock, turn off the whole holder, you just see the bit. So we're going to start with a 1/4 inch bit, and we're going to run that down all the way into a 0.5 millimeter bit. So I'll start simulation, speed it up a bit here. Then we'll move after this down to the smaller bit. I'll slow these down a bit. And then now we get the really tiny bit, which is really taking out that gear to shape it. And then finally we finish with an 1/8 inch that comes in from the side, and that's actually clearing out the side profile and creating a 5 millimeter axle. And there you go. Anyway, so that was the talk, was just kind of showing how that process works, that workflow. And there you go. See ya.